All right. So, good morning, everyone. I hope my screen is visible.
Yes, ma'am. Screen is visible.
Okay. Right. So, in the coming set of lectures, we will be talking about software design. So, we have gained somewhat explanation of understanding of requirement analysis, understanding of the problem. Now, the natural successor in this series of processes in the software development is software project design. So, before we formally start with software project design, I want to understand from you roughly what do you think is the importance of software design in software development? So, what do you think is the importance of software designing in the entire process of software development from scratch?
What do we mean by software design?
Okay, so imagine it like when you create a building. Okay, when civil engineers create a building, they have a sort of architecture or a plan.
Like blueprint.
Like, yeah. So, even before, so let's start with what is a software design as you asked. So, it's basically an architecture or a structure which provides you somewhat overview of the different details in your system, the attributes, the operations, and how different entities will be interacting with each other. So, let's say it's a blueprint of the software that you're making. So, what is your lay understanding of the importance of designing? So, think of it in the context of creation of a building. What do you think is the importance of creating a design before actually implementing that design?
Without any plan, if we start something, we may not reach whatever we are required to do. Like desired outcome may not come. We may go away from the goals, so we can't reach it. And if we have a plan, we may know what are the shortcomings of it, or else we just mindlessly go forward and we don't know where we are going.
Right.
So in that case, project design is so important.
That's right. So, in a way, the design, creation of a software design provides us some direction in which to proceed, and at the same time also equips us in better handling the risks in the process. And Garvit mentions that software designing helps us in restructuring the feature if required. So, Garvit, would you like to throw somewhat context into what you have said that when you mentioned restructuring the feature if required, so how does designing helps us in restructuring of the feature? If you can throw some context around what you are saying so that we can understand your point well. Okay. So yes, so you're talking about providing the feedback, and yes, as in the requirement analysis, we constantly have the feedback. So in the design also, there is feedback involved that helps us to consistently improvise the design and check it vis-a-vis with the requirements that we have analyzed. So basically, again, having a design makes us much more prepared to tackle the problem of the solution or the software that we are trying to develop. So that is why our brain also organizes the information that we are trying to design through a software. So this software designing helps us to have a basic architecture of what to expect from the system, and we throw in the functionalities that the system is supposed to do, and that means designing is one of the steps in the software development life cycle. So we will be in the series of lectures around 2 3 weeks, we'll be talking about different types of software designs, and also learn them through our lab activities. So through all this, the core thing that you are trying to understand is dig deeper and deeper into what your solution or the software is expected to do and perform. So basically, when we talk about design quality, having understood the importance of software design, and we will also keep on talking about in future. So there are two things. Software designing is important, but the quality of the software design is equally important, because the quality of your design will directly manifest itself in the implementation. So that is why a high quality implementation from poor design quality is impossible. So you want to be sure when you are designing, uh, when you're creating a software design for your solution, you need to be sure that the details that are expected to be there, at least at the functional level, are there, because so that you don't have to come back again to designing from the implementation stage if something doesn't go as planned. So design quality generally consists of two things: the quality of your design content and the quality of your design representation. So let me take the analogy from your use cases diagrams. From most of the meetings that I have had, I'm very happy to see that students and groups are actually thinking on how actors are interacting with use cases, but somehow we need to channelize properly how that design content can be properly represented. Because even if the design content is clear, but the way it has been represented is not uh, powerful and robust, chances are that the message may not get conveyed as you would want it to get conveyed. So, design representation is often underemphasized, but it is extremely important, because even when you look at your design representation, you can understand what exactly is happening in your system. So, as mentioned, that high quality implementation from poor quality design is not possible. So, that takes us to the drawbacks of poor design representation. So, designing with high quality content likely will be poorly implemented if they are badly represented. See, human mind is essentially wired to look and feel and interact with things more than textual knowledge. As we say that a picture is worth more than 1,000 words, but I think a better way to phrase it would be a high quality picture or an informative picture is worth more than 1,000 words. So similar case applies to software designing as well. The nature of the representation that you show in your software design is actually a reflection of how clear thoughts are in your mind as a group and also as an individual. So a good quality representation naturally flows when things are clear in your head, and things suddenly don't become clear in our heads, but it is always an iterative process. Secondly, poor representation makes design hard to understand, and problems will not be recognized until implementation or even later. So, this thing is very lately experienced, much later in the implementation stage when you are actually coding and developing, and then suddenly you realize that this factor has not been taken account for during the design phase. So, then you have to go back and do your homework of where this particular module or object fits in the entire scheme of things, and then you again go back to implementation. So this process can be really tedious. So that is why to save time and efforts and resources, the time invested in software designing must be used fully, but make sure that you are not overspending time in over designing your software. There is always a trade-off involved, but an under designed software will always create problems later in the implementation stage. So basically, the design process in software um, is basically a creative process that may not be reduced to routine procedure. And it might sound counterintuitive to you, but it is a highly structured process. So there are certain specific set of actions that need to be performed, and this is a good thing, because that shows that it is not reduced to just whims and fancies. So software designing is a highly structured process, always consists of feedbacks and review, going back to requirements, then coming back to the designing, and then using this communication to refine your design. So the general trajectory in software designing process is that you define your product's purpose, which is your solution or the software product's purpose. You gather relevant data in form of requirements from user and customers and basically the other information, and then you produce an overview of design, a brief, a first draft of your design. And after you are satisfied with something which is called as the context diagram of your software design, then you can plug in the finer details. So you see, every successive steps naturally elongates the previous step. If the previous step is robust and complete and whole in its own manner, then it will be much easier to go forward in the software designing process. So this diagram shows a simplified design process. What is happening is that initially you have a set of initial requirements. So you have gathered a set of requirements and then you analyze those requirements data as we had discussed in our SRS lecture. Then based on the requirements that you have gathered, you need to understand the high level design of how your system is working, how the different entities or the requirements in the data in the design that you have gathered are interacting with each other, and then you refine the document and design, eventually leading to a complete design. Note that this is not a linear process. From this diagram, it should be fairly clear that if it were a linear process, these side lines would not be there. So this diagram just shows that there is communication happening to and fro between different entities throughout the process of a design process. And this is a much simpler way of looking at how do you arrive at your complete design. Note that once you have analyzed your requirements data, then at the same time, you are also obtaining answers to requirement questions, whether or not the requirements I have gathered are justified or not. And then you compare that with your high level design. At the same time, you are validating your design against the requirements. So you see, this is, I would say, a cyclical process. Designing a software is a cyclical process in which it is not isolated from its previous stage of requirement analysis. You have to consistently have a communication. So every time you make a first draft, then you go back to your requirements and see whether your design diagram is doing justice to the functional requirements that you have gathered, to the use cases that you have gathered. And this way you improvise your design process. Let us look at a deeper level diagram. So essentially, this diagram shows the entire software life cycle. You gather requirements, you design. Based on the design, you implement it. After implementation, you perform unit testing, in which you are testing each unit or the subunit of your software, and then later you integrate all of them and check the functionality of the integrated system by integration testing. Then you test the overall system, which also includes the whether or not the non-functional requirements are put in place or not. So that is called a system testing. Then you do acceptance testing, and then finally you decide whether or not the software is fit enough to be used or not. So even in this stage, note that this is also not a linear process. So it's a general level diagram, and it shows that sometimes there is a feedback. So when you are doing system testing, you are also looking at whether or not, so system testing is the overall system that you're working, and definitely if the reason that there is a link between system test and design is the fact that the depth of the design and the accuracy in your design will be very much reflected when you do the system testing. If any gap is there in your software design, that will almost always find its place during the implementation stage or in the testing stage, and then you will be forced back to see, look back at your design. To give an analogous example, so most of you created use case diagrams. You may have noticed that the functional requirements that you had mentioned earlier did not, they, all of them may not have found the place in the use case diagram. So that made you think and rethink over your functional requirements, because technically functional requirements generally form part of the use case UML diagram. So similarly, this link between system test and design reflects the close relationship the entire software and design share. Similarly, between integration testing and implementation. And the user, so user is always an integral part of the entire process of software development. Your users can be different depending on the context you are operating in. So if you do not have end users or customers to directly talk to, you can talk to your project managers or stakeholders and clients. So I hope from this diagram you are able to have this overview that there is so much more that comes to developing a software, and at the same time the next stage is dependent on the previous stage and how strong the previous stage is. If previous stages are lacking or inefficient in some manner, uh, so these differences will always percolate down the layer and complicate the solution and also make the quality of the product much less than otherwise you would have expected. So this diagram you should always remember and see the flow of the information. So it looks a bit like a waterfall model, but in general it just says how the software development generally proceeds, but there is a feedback. So design, when you are at the design stage, you also, so once you have made your design and you want to compare your design with and see whether or not the requirements are being captured in the design. When you have designed and then you're starting to implement, then also you are talking to the design module. So there is always a communication happening between the previous stages, and this is not a rule. I mean, it's more related to the common sense. Obviously, when you're trying to design something, you would want to review it consistently whether or not you are actually moving towards the right direction. Imagine it like I said, trekking. So when you are climbing some mountain or doing some trekking, between your pass sometimes you pause, you may look down and see how far you have come, and then you can estimate how long you are still left to climb. So similarly, in the software development also, because ultimately your goal is to reach at the peak, so definitely these kind of pauses and review are required. So when we talk about design, we talk about first of all the conceptual level of design. So it is very difficult to understand all the requirements and gather all the requirements initially at the first stage, more so when you are new to the project and the problem that you are trying to solve. So the first rule always is to get enough information before you start designing. And now when you will be designing your software on paper, I think all of you have had enough amount of warm up in getting enough information about your projects. So generally a particular approach is followed in which you focus on the high level issues until you know enough to produce the overall conceptual design. Then you produce first draft of your conceptual design, and once you are satisfied with an a overview of the design, like it's a first level picture, then you can plug in the details. So the conceptual design basically provides the framework for assimilating the knowledge you gain and ensuring that you do not lose the important details. So basically, through conceptual design, you are trying to communicate to the viewer of your design what your software or product is supposed to do in a conceptual manner. That generally it takes form of different type of diagrams that we'll be reading in our lecture. So we always start off with a conceptual design of your system. Talking about design quality, again, poor design quality will be reflected in poor implementation. This is always the rule, because design is basically the level of clarity that the team has about the particular software they are developing. So, and because from design your implementation is happening, so that is why the design needs to be complete, accurate, and precise. Now, it's not a one time process. You don't create your first version of the design, and it doesn't become perfect overnight. It has to be improvised, it has to be revised, it has to be discussed critically among your team members and with the stakeholders and clients. Only then, so again, it is a process. Arriving at a complete and accurate software design is not a one time thing, it's a process. There is always a trade off, however. Do not spend too much time over specifying the design. However, under specified design will be expensive and error prone to implement. So, again, this is something that you learn through practice and collaboration and meetings, so that once all the stakeholders associated are somewhat satisfied with the design, and even after consistent meetings no error can be picked up, then you can a bit be sure that it is now good to move ahead without over specifying the design. So again, design quality will be strongly influenced by the quality of information you have about the product you are making. And when we talk about the quality of information, it is directly related to how connected you feel to the problem that you are trying to solve. So that will show the designing aspects. And design complete also involves defining classes and objects that we will study in object oriented analysis and design and object oriented software development. You try to identify interaction between different objects, define the required data and state transformations, and basically specifying what the input and output are related to the system. So, from this slide, just try to understand that for a design to be of good quality, it needs to be complete. So, complete as in it should be able to tell at least more than 90% of information what your system is trying to do. It should be accurate. That means it should be crisp and precise. There should not be a possibility of any leakage of information. I mean, whatever you're trying to represent in your diagram, that should have relevance and importance. Don't just add entities in your diagram which may not be that relevant. And third thing is that you should be careful about your users' needs. So consider the needs of those who will be using the design. So the principal users for the design could be implementers who are basing their implementation based on the design, and the reviewers, the documenters, the test developers. Developers are not the only design users. There are many other design users as well. So again, you have to design your software in such a way that it is comprehensive and easy to understand by the parties who are directly and indirectly engaged. Now, obviously, people who are not from technical domain may not be able to understand a technical diagram of a software design. They might be able to better understand the use case diagram. But again, so there are different kinds of diagrams. Even when I had joined Samsung in 2014 and we had started working on an app, I was not asked to directly go and see the code. They had asked me to spend around 2 3 months trying to understand the architecture of the entire app. And that app was quite heavy. It had around 10 to 12 modules because it was a health based app. So then for 2 3 months, I was only reading the software design that they had created using class diagrams and object oriented diagrams so that I could know how the information and data was flowing between the different modules. Because then maybe any employee would be better suited to work on the code side if you understand the architecture. So similar analogy applies here. When you're trying to create a software, and since you are the ones who are creating it, then you need to be very thorough with the design aspects of it. So as a software engineer, your responsibility when it comes to software design is that you need to have a logical picture of the program, which we call as the conceptual design. And these are some technical concepts that you need to be aware of when you're designing your softwares. And so basically, by identifying the classes, the objects, the functions provided, and all these kind of variables in your system, what you are really showing is how clear you are in the theoretical working of your software. Because from that theory would come up the implementation, and if your theory is robust, then definitely it will be reflected in the implementation that you make. Other than that, design quality is something we call as design precision. So, an imprecise design would be a source of implementation errors. Look at this in this context. When the design is quality is poor, the implementation quality will be poor. Exactly like when the functional requirements are not well understood, then you will have to go to a requirement stage because then you cannot design a proper software. So there is always a two-way communication happening. Sometimes we make the error of that not documenting things or not specifying exactly because we assume that in the process anyone would know how to do this, or let's not bother to document it. But even from my experience, I have noticed that we tend to forget things as we move forward. So that is why it is important to document the important milestones in the design process, because that will help you to refine your design, make it more precise, and this precision in design will be reflected in your implementation. So let us look at this diagram, and so this is like an inverted pyramid. If you look, so in the first process you specify your requirements, in the second you specify a conceptual design, then high level design, detail, and implementation. So there is an importance. Yes, okay, I'll explain. So after this I'll explain, Tarun, is that okay? So note that in this inverted pyramid, every successful every successive step is actually dependent on the previous step. So for example, the conceptual design is directly dependent on the quality of how much quality has been put in the requirement specification. If the requirements specified are not up to the mark, that will be reflected in the quality of conceptual design that you form for your software. If the conceptual design is robust, then your high level design will be much robust. And similarly, if your high level design is good, then your detailed design, you can assume it will be good. And similarly, if all these stages are fine, then your implementation will be robust. So there is always a huge amount of dependency. So this inverted pyramid just shows that each level provides a foundation for the next level. So from this, you can imagine that every previous step is actually a springboard for the next step. So it is not only about putting full attention and focus in one stage, it is also about putting your utmost attention in each pipeline stage of the entire process. So, design level is also something which is not achieved at one go. You keep on refining the design. You start with conceptual design, then you go to high level design, then you go to more detailed design in which you are specifying the processes in the system, the data stores in the system, how the information is flowing from data store to classes to objects, and how different processes are interacting with each other to provide the functioning to the overall system. And then when you have understood the design and the requirement specification, then you can go to the implementation. But you will anyway go to the implementation, but the quality of implementation will greatly depend on the quality of your detailed design, which will in turn depend on the quality of your high level design, the conceptual design, and the requirements specification. So this is how generally uh, designing is imagined in the software development process. Now talking about the documentation. So documentation in terms of designing may not always mean textual documentation. Sometimes you create the first draft of your design, and if you get it reviewed and then you understand that there is something missing, then you go on to the second draft, as we have been doing in our meetings. So the importance of documentation is that you can see how your designing is evolving from a very default conceptual level to a high level and to a detailed design level, because these are the building blocks of your software designing, and that is why keeping track of documentation is important. And later on, when you have designed a final software, then obviously to the diagram you may want, if it's a highly technical diagram, you may want to explain what exactly is happening. If it's a UML use case diagram, and if some of the entities are not easy to understand by the lay viewer, then you may want to provide some explanation to that. So documentation is always an addendum to understand what is shown in the design of your software. Depending on who is reading your design or who is the recipient of your design, you can think of the documentation level that you can do for that. Is it clear now, Tarun?
Can you please repeat, ma'am?
Is it clear now?
No, ma'am.
Okay, so I'm saying that documentation in terms of software designing may not always mean a textual documentation, because in design, if you're creating some diagrams or through graphics, you're trying to understand what your system is doing. So definitely you don't arrive at a detailed designing right from the scratch. It is a process. So that is what we are saying, that when you're trying to design a high level design of your system, moving towards a detailed design, it is important to log in all the details right from the first process. You document, so you create a first draft, then you get it reviewed, then you create a second draft. So at an individual level, this is the documentation that you are keeping with yourself, so that you can understand as a developer how you are progressing. Now, when it comes to documentation of your design for an external viewer, then depending on the technical details of your design, you may want to add some amount of documentation so that the user can understand. For example, if it's a class diagram and you give it to a software developer, you may not need to provide so much of documentation for that to be understood. But if you're providing a similar diagram to someone who is not from the technical background, you may also need to provide how the different classes are interacting with each other, and for that some documentation may be needed. So that is what we understand by documentation. Documentation is actually a way of communicating the ideas about your software to people. These people can be from technical or non-technical background. So based on who is reading the details, you design your documentation. Is that clear now?
Yes, yes, ma'am. Yes, ma'am.
Okay.
Like whatever we do, anything we understand, we'll document it somewhere in some
Yeah,
diagram
it
or
is.
in text, whatever it is, the
Yes,
way we
it is a good
understand.
practice. Yeah, it is a good practice because as humans, we tend to forget the details as we proceed further. When we are doing something, we feel that we will remember this and we will not forget this, but almost always we tend to forget in the future time. So it is always good to implement. Think of it like, for example, you are trying to create a model you're trying to create a predictive model based on a set of variables. So at one point of time, your approach to making the predictive model is different, and you get a certain sensitivity and specificity. And later you are experimenting and you gather a different rate of sensitivity and specificity. But somehow you have forgotten how you have come through that process. So that is why documentation is important. It's always important because it provides context to how your software is evolving over a period of time. So coming to back, if we do not make and document all the necessary high level design decisions in the high level design, you will have to reconstruct them during the detailed design, and you will have to reconstruct them implementation. So this bubble, what it generally means is that if you have not done your homework here, conceptual design will not be robust. If you have not done your homework here, the high level design will get compromised. And ultimately, since all of these are actually paving way for the software implementation, that means that any weak link in the preceding levels will be reflected at the implementation level, and that time it might be very costly to target it. So it is always a judicious approach to focus on the lower levels, because from the lower levels your higher levels are getting constructed. So let's stop with this brief cartoon, and I want you to have a look at this cartoon, and please tell me what you understand when you look at this. So what is it you understand when you look at this image? What do you think is happening here?
He started without any plan and end up making another again. Like, infeasible.
He started.
He started building without any plan right away. So he
Okay.
ended up with what he does. I mean, he did
Okay.
some mistakes again.
Okay. Anyone else? So this person, when he is looking at the what he has created, he's scratching his head, and it reflects as though this is not what he wanted. So this is not what he had exactly planned for. But now that he has created it, he has come to realize that this is not what he wanted to create. So what do you think could have been done in a better manner? So he had an empty slate before he could create anything, but because of certain decisions that he might have taken during the process, he has ended up with something, but that is not something that he actually wanted to create. So we'll stop at this point in this lecture, and I want you to remember this graphic as you are tackling your individual software development projects, and think about what you can do better so that you don't end up in the same situation as this person in the right side. So as Garvit is mentioning, poor designing leads to poor product. So again, at this point, Garvit, of taking from your statement, I would encourage students to think about what exactly is a poor product. In last lecture, we discussed about how do you define the success of a software. So at the same line, because you are in the process of designing your softwares, it is important to identify what would a poor software product look like in the context of your work. What would a successful project look like in the context of your work? So that you can always evaluate them later when you are progressing. So I'll stop at this photo, and I want you to remember this photograph and think over what exactly is the message that it is uh, trying to send to all of you.
Sure, ma'am. Thank you, ma'am.
Okay, thank you so much. I'll see you tomorrow. We'll further discuss software design. Thank you.
Thank you, ma'am.